From the beautiful northern studios of Way Happy, this is Mr. Meyer and L'Hopital's Rule. Now, this is one of those things that you look at and you just go, what? Seriously? I mean, look at that thing in the box right there and just take a second to appreciate what it is. It's always an amazing thing when you find something like this, but at the same time, you have to be super careful. Now, look at in the box. What does it say? It says the limit of some rational function, right? So if you have the limit of something, you can use L'Hopital's rule, and these where I copied this off the internet. That's really f prime of x over g prime of x, and why are we not writing? That's kind of magic we try to do sometimes on the studio shows. And so there it is. That is the magic we use. It is L'Hopital's rule. And what it means is that if you wanted to find the limit, you could take the limit of the derivatives. But it's very specific. It only works right here. If it is the indeterminate form, and the indeterminate form of 0 over 0 or infinity over infinity, that is the one time you can use L'Hopital's rule. Now, we all fall in love with L'Hopital's rule, and we try to use it all the time. So we got to be super careful that we don't use it all the time. All right, let's talk about what we're doing here. So L'Hopital's rule finally welcomes us. And here it is. Take the limit as x heads to 0. So if I look at this right now, if I make x to 0, then e to the 0 is 1, and you get 2 minus 2, which is 0, over 0. And you go, uh-oh, that's indeterminate form, and we're in trouble right off the bat. And so I go, all right, I can't do this derivative unless I do something else. But what else are you going to do? I can't factor something out. I can't, rationalize. I'm really stuck here. This is kind of a pretty mean trick. Well, here's the beautifulness of L'Hopital's rule. L'Hopital says, hey, you know what you do? Take the derivative of the top. And now you finally see why we've been doing these derivatives the whole time. So here we go. Take the derivative of the top. Well, the 2 is just a constant, so don't worry about it. But the derivative of e to the x is e to the 3x times the derivative of the exponent, which in this case is 3, minus the derivative of 2, which is 0, all over the derivative of the bottom, which is 1. And so the limit as x heads to infinity of, what is that, 6 e to the 3x all over 1. What is that limit? Well, if you plug in 0, you get the limit of 6 e to the 0. This is 1. So you get 6. So the limit is 6. How nice was that? That limit was beautiful to find, right? Didn't scare me, and I did a nice job. You can graph it and check. So I encourage you to graph Desmos, put that in real quick, and make sure the limit was 6. So we feel good. Okay, I want to show you that this works also when you talk about things from like the left and right hand side. So let's talk about if you put 0 in, you'd get 1 minus 1 minus 0 all over 0 cubed. Uh-oh, that's again 0 over 0. That is the indeterminate form. Now again, yeah, it's from the left-hand side, so you can use the 0, but then you'd have to think of left-hand side of 0 would be a negative number. So if we had an x, it would have been negative. All right, let's see. L'Hopital says, all right, why don't you take the limit as x approaches 0 from the negative side? It's like take the derivative of the top, which again is e to the x. That's beautiful. Minus 1, which doesn't have a derivative, 0, so that's gone. Minus x, which is derivative is 1. All over the bottom, which is 3x squared. That's that derivative. And then now I can plug in the 0. And what do I get? I get e to the 0. Anything to the 0 power is 1. So 1 minus 1 is 0. And on the bottom, I get 0. Oh, dang it. Still indeterminate form. Hey, I got an idea. Let's use L'Hopital's rule. That's right. You can use it more than once. You can use it like 20 times if you want. So if I take the limit as x heads to 0 from the negative side, I get e to the x, which is e to the x, minus 1, which is 0, all over 6x. And I'm feeling pretty good. Now, what does that give me? I plug in 0, and I get e to the x is 1 over 0. Woo, that's not indeterminate form. What does that actually mean? That actually means we're heading to infinity or negative infinity, right? Something weird's happening. This is taken off. The graph is going up or down. It's reached an asymptote. And so now the question is, well, is it going to infinity or negative infinity? And the way I would answer that question is I would say, all right, let's see, we're plugging in something really small, but it's negative. We're plugging in a negative number. Well, e to a negative numbers, right? That's still going to be positive because a negative just means it's 1 over e. And then e is just a number. It's like 3, so it's like 1/3. So we're going to have 1/3 on top. We're going to have a positive on top. But if you plug a negative into the bottom, that's going to be negative. So that means this whole fraction is going to be negative. And I know it's going to infinity or negative infinity. And if the fraction is negative, guess what? This is headed to negative infinity. So L'Hopital has just helped me decide that it is going to negative infinity. Again, graph it. And I bet as this graph approaches 0 from the left-hand side, I bet it shoots straight down. Actually, I know it does. So not as exciting as I thought. All right, let's keep going. L'Hopital, we're having way too much fun. All right, so limit L'Hopital's rule. This is beautiful, right? I'm going to take the derivative of the top as x approaches infinity. I'm going to, all right, the limit of the top is 2x plus 1 over, oh my gosh, what is the derivative of that? E to the x cubed. So derivative times itself and then times the derivative of the top, or the exponent, which is 3x squared. And there is the derivative. Now plug in infinity and you get, by the way, what did we get when we did this? It was a really big number, infinity, over e to infinity. Well, that's infinity. Hey, another time I can use L'Hopital's rule. So if you plug in infinity now, you're still going to get like something like ridiculously big, like infinity. And then the bottom is still going to be infinity. Dang it. So let's do L'Hopital's rule again. That worked last time. Let's just keep going. And you could see that maybe sometimes you would just get stuck in an endless feed of L'Hopital's rule and you're going to have to try something else, maybe then finally graph it or whatever. Take the derivative of the top, I think is 2. I like that. Take the derivative of the bottom. Oh my gosh, that's an x here and an x here. That's the product rule. So let's see, the 1d2, so the first thing times the derivative of the second thing, so 6x, plus the second thing, 3x squared, times the derivative of the first thing, e to the x cubed, times chain rule says 3x squared. Oh gosh. So there you go. But if we think about this, you're plugging in infinity, you're going to get 2 over a really big number. I don't know what it is, but with all those x's in there, I see an infinity. And so I'm like, sweet, any 2 over infinity, that heads to 0. So the limit should head to 0. And last but not least, it can even work with trig functions, right? Right, let's check. So I take the limit as x approaches 0 of the derivative of the top, right? Now remember, this isn't quotient rule. This is the derivative of the top divided by the derivative of the bottom. So don't try to do quotient rule here. The derivative of the sine, 1 is 0. Derivative of sine is cosine. The derivative of cosine is negative sine. And you're like, sweet, now you plug in a 0 into there. Let's see if I hold down 0 degrees. Cosine is 1 and sine is 0. And so therefore, this heads to either infinity or negative infinity. I can figure that out now by what I plugged in. Oh, wait. I remember this graph. It doesn't go to infinity. Darn it. Who wasn't paying attention? You, watching the video. We didn't pay attention. We didn't check to see if this was an indeterminate form. We just got all excited about L'Hopital's rule. We just started using it, and we never even checked to see if it was indeterminate. Sine of 0 is 0. That's 1 over cosine of 0 is 1. This headed to 1 just by direct substitution, right? So just by direct substitution, it headed to 1. And I accidentally did L'Hopital's rule and would have thought that I got the right answer by figuring out infinity and negative infinity. Oh, be careful. Have a good day. Stay out of trouble. I'll see you tomorrow.